Okay, so let's talk about the question where it's sliding along frictionless surface on the front page, because that's going to be becoming some other stuff later on. So here's your surface, boom. You got 4 different places here, here, and here.
It's a triangle.
So, what are the 2 forces acting on it while it's on the table? Yeah, all you have to do, boom, FG, force normal. Okay, set up the scale, show me what the scale is. What does 1 centimeter equal? Okay, do not just randomly draw a line and think I'm going to know what that means. Okay, these are drawn to scale. It falls off the table, obviously what do you lose?
Force normal.
Force normal. Then do you begin to accelerate?
Yes.
Yes.
And in what's the only direction that you accelerate?
Down.
Downward. Okay? Does it keep moving horizontally?
Yeah.
Yes, but there's no forces acting horizontally. So that becomes the next one when you get to acceleration. So your acceleration vectors are driven by your force vectors. So if all your forces add up to equal to 0, or if there just aren't any forces acting on them, you don't have an acceleration. If you have an unbalanced force, then you have an acceleration. So on B, you're going to have some accelerations. Set up a scale. 1 centimeter equals, say, 10 meters per second squared, something like that. Okay? Draw those acceleration vectors. Then on C, where you're doing your velocities, well, while it's up on the table, you're told that it's moving at 5 meters per second. Okay? So, is there going to be any, and this is where this becomes like a cycle. If this is moving at 5 meters per second, and it is, after it falls off, is it still going to keep moving at 5 meters per second?
Yes.
Yes, and you know that because if you look up above, there's no horizontal acceleration. And there's no horizontal acceleration because if you look up above, there's no horizontal imbalanced force. Okay? So your forces drive your acceleration drives your velocity vectors. Now, does it accelerate vertically? Absolutely. So then you're going to calculate the velocity when it's fallen 0.6 meters, and then when it's fallen 1.2. Oddly enough, what do you know about your velocity at 1.2 versus your velocity at 0.6? Bigger or smaller?
Bigger.
Yeah, it's fallen further. So obviously your velocity at 1.2 meters should be a bigger number than what your velocity is at 0.6. It's fallen twice as far. Is it going twice as fast?
No,
No, why?
that's not how it works.
Because v squared equals v naught squared plus 2ad. And then you take the square root of that, your initial velocity is 0. Now when you're doing this, okay, I've seen this happen and don't. If you're going to use that equation, don't take that 5 meters per second and put that in there as the initial velocity. Okay?
Bad idea.
What happens in the x stays in the x. What happens in the y stays in the y. Does it have a horizontal velocity? Absolutely. Okay? But that isn't impacted by your vertical motion. Okay, so don't put 5 meters per second in there as the initial velocity. All right. So on number 5, because this will give you at least some idea if your answers are right. So number 5, that total time should be between 3 and 3.5 seconds.
Okay.
And on number 6, that total time should be between 5 and 6 seconds.
Uh-oh. Dude, I got 4.8.
Oh, no, you didn't. That's
Yeah,
horribly
that's the
wrong.
wrong question.
Oh, wait, what question are we on?
5 and 6.
Oh. Okay, yeah, that's what I got.
What'd you get 4.8 on?
This one.
On number 8, so here's the cliff,
No, we're talking about
here's the
time.
ball, it's launched off like this. Okay?
It's fine.
Because if your max height is wrong, everything is going to be wrong. So your max height should be a little bit above 80 meters. Not 30.
Oh my.
Yeah.
For which one?
On number 8,
Oh, 8.
Oh.
Oh, we're talking about 8. Oh, okay, yeah, yeah. I didn't know we were talking about 8.
so what's the first thing you have to do when you get that launch velocity?
VY.
Find your Vx, find your Vy. When it lands, does it have the same Vx as when it's launched?
Yes.
Yes, absolutely, okay, absolutely. Now, think about this. It's launched with a speed of 40 meters per second, okay?
44.
That's pretty fast.
Now, if, this is a huge if it landed back over here, okay?
40.
If it landed back over there, what would be the speed there?
40.
40, okay, because it's symmetrical.
But
But it's not symmetrical. It falls an additional 20 meters. So the speed, which is the resultant of your Vx and your Vy when it lands here, should that answer on D be bigger or smaller than 40?
bigger.
Bigger, okay? So if your answer to D on number 8 is not bigger than 40, you have done something horribly wrong.
I got 48.2.
No, you didn't.
Oh,
No, you didn't.
this could not be good.
I'm just telling you. So, it is in the 40s, but that's too big.
Pretty close.
Oh, that's too big?
Yep, that's too big.
What did I do?
I don't know. I don't know.
Oh, damn.
Now, I need to point this out. So like on, of the questions out of the book, on that 22 through 26, those are all multiple choice answers. Write down the letters, because sometimes what you do is that you calculate a number and then you write down the number and not the letter that corresponds with it, okay? So on 22 through 26, make sure they're actual letters and not numbers as your answers, okay? You need to do the calculations, don't get me wrong. On 28, both of those answers, and this is an ish, on 28, should be around 0.5.
Wait, I have a question.
What?
Is it 42.9?
No.
So 43.
You're just randomly
Well,
guessing.
No, I was saying 43 because Dylan said 43.
No,
I
it's
think
not
we
like
were 42 and another guess.
Oh,
Dylan,
43?
Gavin, what did you get for your VX?
22.
Huh?
22. Exactly.
No, you don't.
Cosine 60, right?
Yeah.
Times 44.
Where are you getting 44?
The hypotenuse.
It's 40.
It's 40.
Oh my god, where did I get 44 from? Dude, Mr. Bird can't.
Don't dude me. No.
Oh my, pack it up, bro. Can I just switch mine to 44?
No. No, you can't.
But like,
Because
I
I'm
bet-
not going to redo my answer key because you can't read numbers.
But like, I'm pretty sure all
No.
of my answers are right.
Nope.
Okay. So can I just redo it on another piece of paper?
That's fine. Okay.
Dylan, this is not good.
Your answer to number 72
Gonna take mine.
should be around 700 meters.
I'm not sure I want to do this.
Are we good?
Yep.
Going once, going
Wait.
twice.
Oh wait,
So,
Are we
what
doing the
will
problem?
you-
Come for flex.
Huh?
Can I come for flex?
Yeah.
I need help with one book problem.
Which one?
24B. No matter what I do, I can't figure that problem out.
Which one?
24B on page 91. We didn't have to do that one, did we?
Yeah, you did.
Oh, okay.
Use V naught T plus 1/2 AT squared.
B not T. Wait, what?
Okay. So you got to be able to do this on a question today on the lab. So here's the wall, right?
Yeah.
Okay, whatever. So you know range equals Vx time.
C,
So what do you have for your answer for 24A?
C,
Okay, 4.4 seconds, that's how long it
Yes.
takes to get there.
yeah.
Then if you want to find the height of that point, use 1/2 AT squared plus V naught time. Take your time that you just found and put that in here.
Okay.
You know your initial velocity and you know A is negative 9.8 meters per second squared.
Oh.
It's a function equation. This is f of x, or y in this case, because it's a vertical distance. If you don't want to get picky.
Okay.
Makes sense?
So is the V not
Is your initial vertical velocity,
57.2?
whatever it is. Okay, anything else going on? It's got twice sold. Get these papers, get the safe back with no frizzies. Thank you very much.
What do you quantify as physics?
Oh. You know it when you see it.
Like, is it just the little part that has that was connected to the notebook?
Yeah.
Oh, so.
If you're not sure what they look like, ask Caitlin. She'll show you what they look like.
Wait, it's
What?
what? Oh, frizzy. I thought you said
Oh.
quantify as physics.
Same.
Not frizzy.
Yeah, I did hear quantum physics.
I was like, we're in physics, Luis. What do you mean? What do you quantify as physics?
Not frizzy.
All right, so let me do a little sketch here.
Yeah, but Luis, when your paper is like half a page, I don't think you have to worry about physics.
Boom. I can give you this because I didn't have one question.
Oh, that's great.
Okay. Mr. Burkamp,
What, Gavin?
hang on. 9.8 times 0.5. Oh. Right,
Do we get to use an actual cannon?
squared.
A modified version of one.
Really?
Ooh.
Yo,
Does it go bang?
I see no.
No,
Is that a
it's just my
person?
marble launcher.
No, that's the monkey.
That's still pretty fun though. Is that hanging out? Is the monkey hanging out on the tree?
Yeah.
Yeah.
It's a good trick.
Why are we shooting monkey? Isn't that illegal?
Because we can. Okay,
I got D.
so one of the questions that plays out in, there's two questions that deal with projectile motion. One of them we already talked about, like if you shoot a bolt out of a gun and you drop a bolt at the same time, which one hits you first? They hit at the same time.
Yeah.
So the second one is what's known as the monkey hunter question. Okay, so we'll give a little hat on it.
The monkey hunter question?
So here's the setup on the monkey hunter. So the hunter has a cannon and it's lined up directly on a line towards the monkey that's in the tree. Okay? Directly on the line. Not above, not below, center line. Boom, there you go. The monkey's hanging from the tree. He looks down and he sees the cannon. So, as soon as the monkey sees the flash from the cannon and the ball has left the cannon, at that very instant that the cannonball leaves the cannon, the monkey lets go and begins to fall. Okay? So, the cannonball is going this way, the monkey has let go, and the monkey is falling. So the monkey is falling like this, the cannonball is going like this. Now, there's an assumption that obviously the cannonball will go far enough to hit the monkey, okay? Because if the cannonball only goes here, hey, we're okay. So the assumption is that the cannon is going to go, shoot the cannonball far enough to get to the point where the monkey is.
Like hang?
So the question is, does the cannonball still hit the monkey? Now,
Well,
Not if you let
hold
us
on,
go.
hold on. Let's just think this through. If you're the monkey what's your thought process?
Oh my gosh, the
Not
cannonball's
get hit
gonna hit.
by
Yeah,
a
get
cannon.
away.
But, so,
Bananas.
by letting go and following, what do you, if you're the monkey, what are you thinking is gonna happen?
You're thinking the cannon will go
Where you
about
used
to
to
where
Yeah.
you
Yeah.
were.
You're gonna think the monkey's gonna go where I was.
Yeah.
And you're thinking, oh, I'll fall straight down.
And the cannon.
The cannon's ball is being shot up. I'm gonna fall straight down. The cannonball is gonna go where I was, or at least over my head, and I'll live another day.
So is this like, say the cannonball doesn't have enough to like just nail the monkey? Or like,
Okay.
Are we?
is the cannonball gonna make it to where he's hanging?
Yes,
Oh, okay.
Yeah, so then if the monkey lets go, then he'll be safe.
then he'll be safe. Louise?
If you can do
Are
it
we
fast enough.
calculating the acceleration for the cannonball? I mean, not the acceleration, the velocity of the cannonball?
What about it?
Yeah, I'm just gonna
Is it
delete
gonna
all
be
this,
fast enough to hit the
all these
monkey?
numbers.
Yes, it will be
Actually,
fast enough to get to where
Yeah,
it'll,
I did that one.
like, it might hit like here. Okay?
I have an eraser.
So it'll be going fast enough to get to that path.
Okay.
So let's just focus on the monkey. Let's say, for example, the monkey falls for a half a second.
How much does a monkey weigh?
Doesn't matter. How could you determine how far the monkey fell if you know the monkey fell for a half a second?
9.8 times.
9.8 times 0.5. Or that calculated the speed.
9.8 meters per second.
Okay.
X equals.
2x over a squared.
X equals 1/2 AT squared plus V naught time, right?
Mhm.
Seen this before. Okay? What's the monkey's initial velocity?
0.
Zero. Okay? So you could plug in a half a second squared times negative 9.8 times a half, right? And you're gonna get a number, which is how far the monkey fell. So the question is, does the cannonball fall the same distance? Now, that's a little bit misleading, okay? Because this is how far the monkey's gonna fall, because monkey's gonna fall straight down, the initial velocity is 0. So, even though the cannon is gonna go up, what's the only situation where that cannonball would go on a straight line towards the monkey?
It's
Speed
got
of
a lot
light.
of power.
No gravity.
There was no gravity,
Oh,
okay? If there was no gravity.
speed of light.
So, even though the cannonball is going up, the cannonball is falling from the straight line path that it would have taken if there was no gravity. So the path of the cannon is gonna be something like this.
So it's not
Okay.
like you're just gonna like nail the monkey then.
So it's not like completely straight, so it's more like a.
Yeah, it's a parabolic curve,
Well, that makes more sense then.
okay?
So the monkey
I thought we were- I
didn't-
thought-
So the question is does the distance that the cannonball falls from its straight line, what the straight line path would be without gravity, is that distance the same as the distance that the monkey is gonna fall straight down?
No.
See, I thought
Okay.
we were,
So, let's go shoot a monkey. Unplug the camera, bring back, let's bring it
I
back.
thought we were assuming that like, it was just gonna drop straight on. But now that makes a bit more sense.
Yeah, I thought this cannon was just